determine all the integers represented as x that satisfy the inequality. So how we're going to do this, guys? All right, let me just show you how to do the first one. 5x is less than 30. 5x is greater than or equal to 15. What we do, we're trying to get to have x in the middle only, right? We're trying to get to have what? X in the middle. So what we need to do is to get rid of this number or this coefficient of x. We want to bring the coefficient x to 1. In other words, we want 1x. So we're going to divide by 5 to get x. But when we do that, we have to do that to both sides. Divide by 5 here, divide by 5 here. And so what happened, this is going to give us 5, 5 goes 1, goes 3 times. 5, 5 goes 1, goes 6 times. So we have is 3 less than or equal to x less than 6. So if you catch that, yes or no? I'll go over.
Yes.
Not exactly.
I catch it.
Go over.
Okay, no problem.
Yes, please.
Okay, so we have 5x here, right? We want to have x. So how do we get rid of the 5x? It's like saying 5x equal 20. How do I find the value of x? 5 times 4 is 20. So x is 4. So what we do to one side, we do to the next. So this gives us x is equal to 5, 5 goes 1, goes 4 times. X equal 4. That makes sense because 5, 4 is 20. It's the same thing that we want to do with the inequation as we did with the equation a while ago. What we do to one side, we do to the other sides. We have 3 sides in this case. The middle, we want to get x. So we're going to divide by 5 to cancel out the coefficient. But what we do to the middle, we do to this end and the other end. 5 goes into 15 3 times. 5 goes into 5 exactly. 5 into 15 goes exactly 3 times. 5 into 5 goes exactly 1 time, so we have 1x. And 5 goes into 30 exactly 6 times. So this is my solution. Right? They said determine all the integers. We can just leave our answer like this. This is all the integers. Meaning that x is great. Integers are numbers like we can count. Like 1, 2, 3, 4. Those are natural counting numbers. Are natural numbers. But we also include 0 as an integer. Right? So it's not just counting numbers. So now we're talking about all whole numbers here, right? But then we have some numbers below 0. We don't really call them whole numbers, but they don't have any fractional parts. So we refer to them the negative of whole numbers. Like negative of 1 is negative 1. Negative of 2 is negative 2. Negative of 3 is negative 3. And so forth, right? And these numbers all make up what we call the set of integers. We use the letter Z to represent the set of integers. Right? They don't have any fractional parts. Not negative 3 point anything. Just negative 3, positive 3, negative 2, positive 2, negative 1, positive 1, 0. All these going on to infinity in both directions. So we talk about the values of x. You can write them out. This is saying that x is what? We're going from x to this direction. What we're saying here, we're saying x is equal to 3. Right? We're including 3 in our answer. But notice that the big part of this, the big part here, face the bigger number. So like I have 10 here and 6 here. I'm saying that 10 is bigger than 6. If I'm going this direction, I'm saying 6. And I talk about the small part here. So 6 is smaller than 10, or 6 is less than 10. But once I'm reading in this direction, I hit the big part first. So I say 10 is bigger or larger or greater than 6. So it depends on which direction I'm going from. The small part, the beak, faces a small number, and the opening faces the bigger number. It's like a mouth and the beak. So the mouth faces bigger number, the beak faces smaller number. So 10 is greater than 6, going from right to left. Going from left to right, 6 is smaller than 10. So I'm reading from x to 3, I'm saying what? X is what? I'm facing the what? The beak or the mouth? So
Can
open.
you repeat that, please?
Okay, think of this as a mouth. All right. This is when the mouth is open. This is when the mouth is what? Closed.
Oh,
Right?
not the part, just the question.
Oh, the question. You understand that part, right?
Yes, sir.
Okay, awesome. Oh, what I was saying now is that when you're reading from x to 3, how do you read that? What do you mean first when we move from x to 3? You say x is greater than or less than 3?
Less than.
No, don't guess.
Greater. Greater.
Look at it.
Greater than or equal to.
The opening face is
Greater than.
the opening face, the bigger number, right? This is the opening. So x is greater than 3. If you're reading from 3 going to x, you're saying what? 3 is what? Smaller part. 3 is less than x. Got it?
Yes, sir.
Or if you know that, if you know it's from going from left to right, you say 3 is less than x. Then obviously going the opposite direction means x is greater than 3. And if x is greater than 3, what are the values of x? What integers are greater than 3? Integers. That is, we're talking about numbers without fractions. Fractional parts. What numbers are greater than 3? Give me the first number greater than... Huh?
5.
You missed one. 4. 5. But no, the numbers must be what? This is telling us
X said less than 6, so it stops here.
it must be less than 6. Because we're reading from x to 6, we're meeting the small part. So x is less than 6. So we're not going to include 6 in it because we don't have a dash on it to include 6. So we're leaving out the 6. So we're stopping right there. So these are the numbers. 3, 4, and 5. All this fancy thing here that we have here, all is saying x can be represented by the numbers 3, 4, and 5. So in other words, I can actually remove this x value here, and I can put 3, and it will be true. Because 3 is equal to 3. That's what this dash means. And 3 is what? Less than 6. I can remove it and put what? Put 4. And this is saying 4, going to the left, 4 is greater than 3. And 4 is less than 6. And I can also put 5. That's the last integer I can put there. 5 is greater than 3, but 5 is less than 6. I can't put any other integer. Integer meaning numbers without fractional parts. I can't put them. For instance, I can't put a 6 here. While 6 is greater than 3, 6 is not less than 6. So that would be wrong. That would not satisfy the inequality. It says it must satisfy the inequality. That's why we chose 3, 4, and 5 only as values of x. But when you're writing the solution, you don't need to give me this. Have it in this form is sufficient enough. However, you will show your knowledge of it to a greater degree when you actually put it on the number line. So how do you write this on the number line? And what we need to do on the number line, draw the number line, right? We can have our 0. Right, nice to put the origin. But the values that we're talking about are all after 0. Alright, so that we just need to have the two numbers we're dealing with. We're dealing with 3 and we're dealing with 6. So let's ensure you put the two values they're talking about. We're talking about 3, as we have here, and 6. So you want to have those on the number line. Then you're going to put circles, right? Okay, how are we going to do this though? We're going to put circles on 3 and 6. Which one of them do we need to shade?
3.
Right, we need to shade the 3, yeah. That's correct. Why are we shading the 3 only? Because we're including 3 in our answer for x, right? Should I shade 6?
No.
Right. And the values we shade in between the two circles as well. Because the answers lie between 3 and 6 as well, right? In terms of 4 and 5. You want to put x is less than 6, less than or equal to 3. That's it. What about this one now? Let's simplify this one quickly. Let's solve this one.
Divide by 4.
Divide by 4. Divide by 4. Divide by 4. What are we going to get?
X in the middle. It is not 2?
Yeah, it's 2. I made a mistake. That should be 2. What should go here?
5.
5, yeah.
Sir, it's me. I wanted to ask earlier. In the case of the other question where you divided all the terms by 5, just like how you're doing now with the 4. I wanted to ask, why is that?
Because you want to get what you want to identify the value of x, the values of x. If you don't divide by that number, then you're not going to get x. For instance, if you divide by 1, you're still going to have 5x. If you divide by 2, you're going to get 2.5x. You want to get 1x. You want to find the values that represent x. We want to get 1. So the only way to get 1 is to divide 5 by 5. We want to get 1x. Not really 1, but 1x. One lot of x.
Okay.
You want to get the number that multiplies x to be 1. So to get 1x, we need to divide 4 by 4. So it's like when I showed that early on, that 5 times the number give you 20. How do we find out what the value of x is? We know that only 5 times 4, right? And we know that only 5 times 4 give us 20, right?
Mm-hmm.
So the only way we can do this is to divide by 5 and divide by 5. 5 is the only number we'll divide by to get us what 1x is. So 1x is equal to 4. Which means 2x is equal to what? 8. Which means 3x is equal to 12. 4x equal to 16. And 5x's will be equal to 20. Because x is equal to what? 4. 2 4 is 8. 3 4 is 12. 4 4 is 16. 5 4 is 20. So just like with equations, we want to find what x is with inequation. In equation, unlike equation, we have one value for x. For inequation, well, especially if it's a linear equation. In equation, we have more than one values. Most of the time, okay? So, this is telling us x range from what? 2 to 5, isn't it? Right, guys? So, we'll have, on the number line, what will we have? We're talking about 2, and we're talking about what? 5. Right, guys?
Yes, sir.
Yes, sir.
Circle. Circle. Will we shade any of them?
2.
Right. Is the answer only
Shade
2?
the line.
Yeah, we cannot.
Shade the line.
Yeah, we shade the line between, because the answer is not just 2, but the number is in between 2 and 5. And then we write the answer. We just write the thing on it if you want to. 2 is less than or equal to x, less than 5. We don't have to write. We don't have to write out anything. If you want to write out what the values of x will be, we know that will be what? From 2, 3, 4. Well, we're not. That's it. Because we want integers, right? So we're not going to look at 2.5 and 2.1 on those things. Integers meaning positive whole numbers and negative whole numbers, including 0. That's it for 2. All right.
Wait, so we don't have to write the number line in example.
Like this until you put your answer on the number line. All right. So let's say you had a 0 here. Your answer range from 2 to what? 5. Circle. Draw lines through a circle here, and you shade this. And just basically shade here. Right. Don't shade the circle here though. That's it. What you want? You probably would want to write it on it. That's it. That's for the second one. All right. You won't get any as challenging as these, but these are not really that challenging. Let's do that one quickly, then we'll move on. CXC can actually give you one of these. So I think, I was preparing for the exam, but CXC as well. Which one would you move first, the 3 or the -2? And think of equation. Which one would you move first if you had an equation?
The -2.
No. You move the multiplier last. Like when you change the subject of the formula, like you have -3. What if you had -2x plus 3 equals 6? I want to find the value of x. And it's an equation. You would move the -3 first. You move what's affecting everything else first. Right? The 3 is being added to the entire -2x. But -2 is only multiplying what? X. So you can't move that first. You have to move what's affecting everything else. It's like your socks and your shoe. Which one can you move first? Which one is covering everything? Your socks or your shoe? Your shoe.
Your shoe.
But that would have been the last thing you put on, right? After you put on your socks. But it's the first thing you're removing. So move your shoe first and then your sock. So it's the same thing here. You're moving what's affecting everything else. The 3 is affecting the entire -2x because 3 has been added to -2x. Right? So we're adding to the entire -2x. But the -2 is only multiplying x. -2 is not multiplying 3, so we can't move it. So move this first. And that gives us -2x equals 6 minus 3. Give us -2x equals 3. Now we can divide by -2 on both sides. And this will give us x equal -1.5 or -1.5. If you plug it back in there, you'll see that's true. -2 times -1.5, that will give us +3 because negative times negative will be positive. So +3 plus +3 give you +6. If we did it any other way, we would have gotten the wrong answer. So the same thing here. We remove the 3 first. So we subtract 3, right guys? But in this case, we have to do that to both sides. So we subtract 3. So we're going to have to subtract 3 here, and we subtract 3 here as well. Right? Are you following? So 3's cancel out there, will give us, come out to be 0. So we're left with -2x plus 0 or -2x. So we're left with -2x less than, what's -7 minus 3? That's -10. What's 6 minus 3? That's 3, right? 6 minus 3, that's 3.
Okay.
But it's the same concept. We want to remove the +3 first. So we subtract 3. Because it's a +3, so we have to use -3. If it was a -3, we have to use +3 to get rid of it. So -3, -3, -3. And we'll be left back with what? -10, -2x, and 3. Calculator can help you. -7 minus 3 in your calculator will give you -10. We know this is going to give you 0 anyways. 6 minus 3 is 3. Alright, what's the next step after this? At this stage now, you're back to your familiar territory. What do you do next? You divide by what?
By 2.
Not by 2, but by what? What number is multiplying x?
2.
No, look at it carefully.
-2.
Right. You have to look at what sign is in front of the quantity always. That'll be a big mistake with algebra, right? You have to look at the sign. See, because you're going to divide by a negative number, when you're dividing by a negative number or multiplying by a negative number with inequations, right? Here I wasn't dividing, I was subtracting here. Because I subtract 3 from here, I subtract 3 here and subtract 3 here. When there's a division line, I actually show the division line. But once I'm dividing by a negative number or multiplying by a negative number, with inequations, we have to do one thing. You know what that is? We have to flip the sign around. That's the one major difference, okay? We'll flip the symbol around. If you had a dash underneath it, we still flip it around, put a dash underneath it. Okay, and so this will give us +5 is greater than x is greater than -1.5 or -1.5. And so our solution on the number line will look like what? We have 5. Well, 5 goes, let's put 1.5 here. 1.5, put a 5 here. Is it negative 1.5? Yeah. Put a 5 there. So we're going to have circle here, circle here. Are we including any of them? No.
No.
So our solution will only be, we only shade in between. Okay, so there's only one difference. When you're dividing by a negative number, we have to do what with symbol. At the point of dividing by the negative number, that's the point we actually flip it around. Understand that?
Yes, sir.
Okay, one last one. Let's do this quickly. I'm gonna go through that quickly. What do I need to get rid of here? What first? What do I get rid of first? Talk to me, guys.
Nah, the plus one.
Plus
Nah,
one.
plus one.
Yeah. So how we get rid of it? It's a plus one, so we use what?
You took that one from the
You
10,
can
the
subtract
1,
one
and
from
Yeah.
everything.
Yeah. Very good. So we have 9 less than or equal to 3x
the
less than or equal to 15. Very good.
15.
All right. What do we do now? Divide by what?
3.
3.
Divide by 3. Very good. So we're going to divide by 3. Divide by 3. Divide by 3. 9 divided by 3. Give you 3 exactly. So we know no remainder. 3 goes into 3 exactly. So that's 1. Or 1x. Which can write like that. We don't have to put the 1 in front. And 3 goes into 5 exactly, right? Sorry, 3 goes into 15 exactly 5 times. That's our solution right here. Alright, so we can actually find a little space there. Sorry about that. On the number line. What numbers we're going to write up? We're going to put on it. What are the two numbers we're working with?
3 and 5.
3 and 5. Circle, circle. What do we do? Shade any or leave
Shade.
blank? Shade.
Shade both.
Shade both.
And
in
the
between.
line in between.
Yeah. Alright. 3 less than x less than equal to 5.